morning. It's a pleasure for the University of Vigo and for the campus, the Mar of the Sea, to have today with us Ragnar Arnason. Arnason is a professor of fisheries economics at the University of Iceland. He has a master's degree in mathematical economics and econometrics from the London School of Economics, and he received his PhD in natural resource modeling from the University of British Columbia in 1984. He is in this moment the chairman of the Institute of Economic Studies at the University of Iceland, and he sits on the board of several companies and institutions such as the Danish Bank, the Icelandic Central Bank, and the International Institute of Fisheries Economics and Trade. The Professor Arnason has advised the Icelandic government on fisheries, among other subjects, and he was instrumental in developing the ecosystems in the Icelandic fisheries in the 1980s. In fact, Iceland was one of the first countries, I think, with New Zealand perhaps, in introducing the ecosystem as a regulatory instrument. He has also provided advice on fisheries management and environmental uses to the governments of several countries in Europe, America, Asia, and Africa, both in a private capacity and working for different international institutions, in this case, as the World Bank and FAO. He has an extensive publication record with several books and over 150 papers in the majority of reference journals for fisheries economists, like Marine Resource Economics, Marine Policy, Fishery Research, the Canadian Journal of Economics, the European Economic Review, the American Journal of Agricultural Economics, and the Annual Review of Resource Economics. His more recent research has been in the areas of community fisheries management, fishery rents, fisheries losses, and fisheries enforcement. Thank you so much, Ragnar Arnason, for coming to Vigo for this conference. Thank you.
Well, thank you very much for this introduction, and good afternoon, everyone. It gives me great pleasure to be here and having been invited to address this project, Campus do Mar. I've been to Vigo before, and I'm always pleasantly surprised by the beauty of the place, and by the good food, and by the friendliness of the people. Just a few words about the project, Campus do Mar. I think this is a very, very important project. Fisheries are important in Europe, and fisheries research is not sufficiently developed compared to many other areas of economic life, and therefore it's important, given the complexity of fisheries problems, to have high-level university research in the area, and Galicia in Spain is exactly the right place to do something like that. I can state on behalf of European fisheries economists that we're all very excited by this project, and we wish it well. My topic today is on global warming and fisheries, and I added the term risk to the title because when it comes to global warming, the usual risk associated with fisheries is multiplied. No one really knows about the global warming, how that will evolve and to what extent, and then what effect that is going to have on ecosystems and therefore fisheries in the ocean. So let me go ahead, and basically my talk will be divided into these three parts. First of all, I'll give you a little background on the current predictions about global warming for the current century. Then I'll talk a little bit about global warmings and fisheries in general, and what the relationship between a warming climate and fisheries might be. And then I'll talk about the implications for fisheries policy, which of course is the practical thing we can do to respond to changing conditions. I will talk about the optimal fishery, the economically efficient fishery, the type of fishery we all strive for the good of society. I'll say just a few words about the competitive fishery, which is, by competitive fishery, I mean basically the common property fishery. A fishery that does not have the institutional structure that allows it to be anywhere close to being socially optimal. But because of the shortness of time, I will just say a few words about that. And then finally, I'll give you a few ideas about international fisheries agreements, which are ubiquitous. They're all over the place and very, very important. And those will be put under added strain because of the impact of global warming, or I should say because of the possible impact of global warming. Global warming is likely to move fish stocks around and increase and reduce their productivity, and therefore current agreements about sharing the benefits from these stocks will be put under strain. They will become outdated to a greater or lesser extent. So that is something we are already seeing happening, and I'll give you an example of that. First of all, let's go to global warming and wonder about what we might be faced with during the next 100 years or so. There is, of course, a lot of research in this area, many large-scale meteorological models, and they're all in reasonable agreement. There will be global warming during the next 100 to 200 years. Irrespective of what we do now, it's going to happen according to these models. All we can do is to affect slightly the warming trend, and especially towards the latter part of the period. We can do hardly anything to affect global warming during the next 50 years. The mean prediction is for a 3-degree increase in temperature centigrade by the year 2100, but the confidence interval for that prediction is very wide. It's from 1 degree centigrade to 6 degrees centigrade. The driving force, of course, is greenhouse gas accumulation. And as I said, there is very little we can do to change this now. Even with a drastic cutback in emissions, greenhouse gas emissions, we will still see a 2-degree increase in global temperatures, according to these models, by the year 2100. And this is just to give you an idea about the various scenarios that have been produced by the international panels on climate change, that you probably know about. The black line you see there, black curve is history, essentially, and the various possible outcomes depend on the various scenarios for greenhouse gas emissions. If you wonder about this low line here, which represents about 1 degree increase in temperatures by the year 2100, that is if we keep constant concentrations of greenhouse gases in the atmosphere relative to the year 2000. We're already well past that, so we cannot really reach this level. This red curve, which is towards the upper boundary, is basically a continuation of the current policy of economic growth, more or less powered by fossil fuel burning. Not any intensifying, but more or less the same policy. And right here at the right-hand part of this diagram, you see the various predictions and their confidence intervals. You may wonder about this one because it has the highest possible prediction, over 6-degree increase in global temperatures, and that is the current economic growth policy with emphasis on fossil fuels, but not added emphasis, but the same emphasis that we have had in the past. So that's a continuation, basically, of the common trend. All the various scenarios, the lower predictions are for more saving in the emission of fossil fuels. B1, if you wonder about that scenario, that is a scenario that downplays the emphasis on economic growth and re-emphasizes the conservation of nature and the climate. So the lowest predictions basically are around here, 1 to 2, well, basically 2 to 3 degrees increase in temperatures with some confidence interval, and the highest are more like 3.5 degrees. This is another diagram I lifted from the IPCC homepage, and this is just trying to illustrate to you the distribution of the global warming around the globe, because it's not going to be evenly distributed. This is the picture for 2020 to 2029. So basically in 10 to 20 years' time. And you see the darker the color, the more increase in temperature, and you see the biggest increases towards the North Pole, the Arctic areas. But happily, Iceland, my home country right here, somehow escapes this. It seems that we never have to pay for anything. Spain, pretty good. It's no dark colors, so that's not really bad for Spain. By 2029, it's not too bad. It's an increase of maybe 1 to 2 degrees centigrade. I emphasize, I'm not advocating these predictions. I don't know whether they're correct or not. There are doubters still, but these are the mean predictions of these models. So this is the official, the global official prediction. The real warming we are going to see towards the end of the century, and that's here on the right-hand side, towards the end of the century, and you can see the dark colors, so basically covering the whole globe at a different rate. This is the economic growth policy. This is the low growth policy with emphasis on the environment. But even so, you see huge temperature increases. You see here towards the North Pole, 3 to 5 degrees increase in temperature. Here, if we have the current economic growth policy, which I actually, as a political scientist, I have a degree in politics, think is going to be is likely to happen. We are seeing up to 6, 7 degrees increase in global temperature, or not global temperature, temperature up in the high north. In Siberia, northern part of Canada, Greenland, and the Arctic areas in general. Still, happily, you see that Iceland is more or less escaping all of this. In the northern part, we can go to get some heat. Southern part, we are basically, nothing much is changing. Spain, 4 or 5 degrees. And that's probably too much, given that you're already quite warm. I don't know about precipitation, that may increase or go down. I don't know about that. So, what's the impact of all of this on fisheries? We know very little about that, but there are certain things we know for sure. That global warming of this scale is going to alter fish habitat. It's going to affect ocean temperatures, first towards the surface or in surface layers, and then deeper down through ocean currents. Ocean currents are going to be affected, but no one can predict how. There are some predictions saying that the Gulf Stream, which is important for Spain and Europe and Iceland and these countries, may get weaker. But that is being debated hotly. No one really knows about these things. Upwellings, very, very important for many fisheries, are going to change. They depend on currents, temperature gradients, and other things, and that is going to be affected. So upwellings may disappear or appear or diminish or increase in intensity. Water chemicals, all salinity and all these other trace elements in the water are very important for fisheries, will also change because of the other factors. So, fish stocks will be affected, biomass growth will be affected, it may go up, it may go down, it may become more variable. Species distribution is going to change, there will be a different configuration of species in different areas, and their geographical range and location will change. So if this happens, we are going to see quite drastic changes, well, quite significant changes and sometimes drastic changes in the location and size of fisheries. This is just an example from history. We know these things. This is the cod fishery or the cod stock, Iceland-Greenland cod stock, which is a big cod stock. It has average landings of 300,000 to 400,000 tons over more than 100 years. And these colors here indicate the distribution of the cod stock depending in various periods that are differentiated by temperature. So if you look at the red area first, that's the distribution in the 1980s, which was an unusually cold period in these waters. And you see the distribution is towards the southern and western part of Iceland, and as few concentrations here close to Greenland. However, in a warm period, in 1930s to 1960s, which was a fairly warm period, 1 to 2 degrees centigrade warmer than average, you see the distribution more than doubles. It's like 5-fold distribution. It's the green area on top. And then you see these blue areas here, which are exceptionally warm years. And the size and productivity of this particular fish stock, which is pretty important, even in Spain, because bacalao is imported into Spain from Iceland, among other places. So the productivity of the stock depends on the extent, the range, the geographical range of the stock, and it's extremely variable depending on temperatures. And these are no predictions, this is known. This is historic, these are historical facts. And we may see the same thing happening globally because of global warming. And this is just more of the same. This is indicating the increase in catches off Greenland when temperatures go up. This is from 1910 to 1940, and this is 45 to 1995. And you can see here, these lines are indicating lower temperatures. You can see how the cod fishery goes down, and basically the cod stock off Greenland totally collapsed. It disappeared. Okay, here's another example. A very, very big stock of fish, Atlanto-Scandian herring stock, used to be 20 million tons. 20 million tons, one of the biggest fish stocks in the world. In the 1950s and early 1960s, and this is a stock that spawns off Norway. This is the North Atlantic here. And these are the feeding migrations toward Iceland and Greenland. You can see the cold frontier, this blue curve here. And these were the good times for this fishery stock, huge stock of fish, very big fishery, and this was a warm period. This stock collapsed in 1967, going from, at that time it was probably about 10 million tons down to a minimum of 20,000 tons. It barely survived. And this is just before it collapsed, and you can see that there's a cooling trend going on. The cold frontier is going south and east, and the migrations are getting more constrained. 1972 to 1986, the stock had completely collapsed, and this is the location of the stock at that time. This was a cold period in the North Atlantic. 1995 to 1999, the stock had recovered again, mainly by luck, because it was almost exterminated. And there was no fishing for 25 years. After 25 years, we had a few good years classes, and the stock rebounded. And you can see how with a warming period, how the stock is starting to migrate again and extend its geographical range, which is crucial for the size of the stock, because they need to feed, and they feed on plankton, and so the more extensive the plankton distribution, the bigger the stock can be. So, these are just examples of what might happen on a global scale under global warming. A few words about the uncertainty. We know almost nothing here. We don't know about the extent of global warming, we don't know about the timing, we don't know about regional changes. We have predictions, but they're extremely uncertain, extremely uncertain. We know even less about the impact on the fish stocks. We know little about global warming, we know less about the impact on fish stocks, partly because we know little about how global warming is going to affect the habitat conditions, upwellings, ocean currents, things like that. And then, of course, the response of the fish stocks is going to depend on ecosystem responses. And ecosystem responses are extremely complicated. I don't think anyone really understands ecosystems. I know of biologists that have been studying ecosystems in fairly small lakes for decades, and they still don't know how it works, let alone ecosystems in oceans. So most of what we think might happen is guesswork. All we know is that if global warming is going to happen on this scale, there will be changes, significant changes, but we don't really know how. And then, of course, we don't know about what's going to happen to fish prices and input prices, because global warming is going to affect economies. And our responses to global warming, trying to avert global warming, might be extremely costly. All of these things are going to affect economies. and therefore fish prices and the prices of inputs into fisheries. So that's another effect. So what about fisheries policy now? What are we going to do in these circumstances? As I said, we know little. We just don't know. We just know that there are going to be important changes. But we know little, therefore we are faced with a huge degree of uncertainty and therefore risk. Anything we do is fraught with dangers. We may make a big mistake. So what should we do under those circumstances? And that is going to be the rest of my talk. Rest easy. You know, I'm not going to give you the answer because I don't know, but I will claim that there are a few things that we might actually plan for. But basically, we have to plan for the unknown. We have to be prepared to adjust to whatever will happen. So, two things in terms of policy. What should we do in fisheries that are reasonably economically efficient? And those would be fisheries based on property rights in some form, individual transferable quotas, turfs, and other reasonably strong property rights. Already fairly efficient or on the path to becoming efficient. Fairly reasonably many fisheries around the world, by my count, probably about 25% of the global catch of fish in the ocean is under individual transferable quotas in some form. So the global fisheries is becoming rapidly more and more economically efficient. But still, we have the big chunk of fisheries, ocean fisheries, that are what I call competitive or common property fisheries. And those are characterized by little or no profits, little or no social benefits, and usually quite a big threat to the survival of the stocks. Usually the stocks are depressed, sometimes decimated, and they are, in some cases, are on the brink of exhaustion. So if there's an environmental change, that might tip the scales. And I will tell you right now, because I don't have time to go into this in any length, that the policy here is to avoid stock collapses, to do protective measures for the competitive fisheries, common property fisheries, just to protect the stock, avoid disasters, stock disasters. Okay, what we can do, or what I can do, is to look at the issues theoretically. It's a complicated problem. Importantly, we have to realize that intuition is often wrong. Economists know this very well, that when you have uncertainty and risk, sometimes what seems to be intuitively right is wrong. We should do something totally opposite to it. And that happens in this case too. What we need before we go into empirical research is a good theoretical framework. We have to appreciate the complexities of the problem before we start to collect data. We have to avoid jumping to the wrong conclusions or wrong solutions. If possible, we should get an idea about the right solution. What is it likely to be? You know, sometimes theory can help us in that. And we need the theoretical framework to guide us in the empirical work. Empirical work without theory is like a man lost in the woods or in the fog. You know, you need theory to indicate to you what you should research empirically. Empirical research, if you want to research everything, is impossible. You have to focus your efforts on something that is likely to be helpful. And that's why we need theory. So, the basic model is something like this. I will not spend much time on this, although this is fundamental because it's technical. We have a biomass growth function here that depends on biomass, that's x. X is biomass. It depends on time here, or you can regard T as temperature. You know, time. So this function is moving with temperature over time. Biomass growth is increasing or decreasing with temperature. And then we have a random effect here. There are parts of all of this biomass growth we don't know. We don't know how time or temperature is going to affect it. Same thing with the profit function, and here by profits I mean social benefits. Quite often social benefits are synonymous with profits, business profits, but not always. But I'm always talking about social benefits. I'm assuming we're talking about social benefits. Same thing, we have the profits as a function of Q, quantity of harvest, biomass, and time. The profit function is going to move with time, with temperature, for the reasons I've already explained, and there's going to be a random term here. So both of these key functions of any fishery are stochastic. And what we want to do is we want to maximize the expected benefits of the profit function or social benefits over time, the present value of that. If you don't like expectations and integrals, don't worry about this. We just want to maximize our benefits over time in present value terms. The present value of the most likely benefits over time. We want to maximize that. But we have to take account of the evolution of the stocks. That's this expression. And we start at a certain stock level, and we are restricted to have harvest and biomass at least non-negative. And the bottom line is that a problem of this type is extremely difficult to solve. It's relatively easy to write it down, but really, really difficult to find a solution. Like most of life, difficult to find good solutions. So this is the non-stochastic case, just ignoring all stochasticity. These are optimality conditions. We can write them down theoretically. And they look like this, and I'm not going to tire you with going through them. The point is that without stochasticity, the optimal policy can be myopic. And that's a technical term. It means that very often you don't need to predict the future to do the economically correct thing. You just have to adjust to the changes as they happen. And that's called, you can be myopic. You don't have to have long vision. You can just respond to the conditions every year. This is really, really important, because to the extent that this is true, it means that we don't have to rely on uncertain predictions about global warming and other conditions. We can just make the adjustments when necessary. Just like when you're driving your car, you don't need to know the conditions of the road a few kilometers down. You just react to the current conditions on the road. However, this thing, you can only be myopic if there are no blocked intervals, so to speak, if you don't hit any boundaries. If you can always, if there's nothing stopping you from adjusting the fishery in this case, but there might be political constraints saying you cannot reduce fishing effort this much in 1 year. Or there might be capital constraints. You cannot increase harvest to the level that you want because you don't have the capacity. Things of that nature might happen, in which case you have to predict. Every businessman knows this. If he has a factory with a limited capacity, he better predict the demand for his product. Okay, in any case, the changes, non-stochastic changes to the environment, global warming changes, will fundamentally affect the rate of discount, the interest rate that you use in your calculations to do the optimal policy over time. And so if this is the market rate, this is the bank rate or something that you use, then because your profit function is changing over time because of global warming, you will act as if the interest rate has changed. And fundamentally, if your marginal profits of harvest are increasing, your interest rate, your imputed interest rate, if you like, is going to be reduced. And that means you're going to be more conservative. Sounds counterintuitive. But if your profits of per unit of harvest, maybe because of increased prices, possibly because of global warming is going up, you should harvest less, according to this. Why? Because while the prices are rising, you want to save on the stock. And then you want to harvest the stock when the price has risen. And you get more for each unit you land. This is not just price, these are all the conditions of harvesting. Maybe because of global warming, the fish are getting closer to shore. Or maybe they're getting further from the shore. Or more difficult to catch, or more easy to catch. Who knows? All of these things may happen. So, in the case where global warming is basically helping your operation, so this is that particular case, you should do something like this while things are improving. So this is the path of harvest over time. This is before global warming starts to happen. You have a constant harvest rate, maybe optimal harvest rate. And then things are starting to improve and they're getting better and better. You cut down on harvest, you save on the stock. And then when things have become as good as they're gonna come, then you're increasing harvest and you end up harvesting more in the long run. So you move from a fairly low harvest level to a fairly high harvest level. But you take this strange bypass, if you like, or strange route at the outset. So this is what I call counterintuitive. So this is the optimal policy if you know what's going to happen, if you ignore stochasticity. And I can show this here. Some of you may have seen these kinds of diagrams. They're called phase diagrams. You have harvest here, you have biomass here, and this is the curve where biomass is not changing, the biomass equilibrium curve, and this is the curve where harvest should be constant. And the optimal long-run equilibrium is right here at the high biomass level and at a certain harvest level. So now let's assume that we have had global warming, and the global warming is increasing the productivity of your stock, which might easily be the case. And it's also increasing or changing your harvesting conditions in the way that this red curve moves to here. So the new long-run equilibrium is here. So if global warming has already happened, So this is the case where you have a situation without global warming, and then global warming happens. And the end situation is indicated by this curve and this black dotted curve. So this is the old equilibrium, this is the new equilibrium. And the question is, how should you respond to a change, a sudden change that is not foreseen, but it happens? This is not, of course, realistic. Of course, we'll see global warming coming. It's probably going to come gradually. But for simplicity, let's assume it just happens one day. And let's assume you are here at this equilibrium. You are maximizing social benefits from the fishery. Now the situation has changed, and the long-run equilibrium is here. How should you move your harvest and biomass from this equilibrium to this equilibrium? Well, you should initially cut down on harvest, and you should follow this long-run optimal path towards the new equilibrium. Cut down on harvest because you want more biomass, and to increase biomass as fast as possible, or in an optimal way, you should cut down on harvest, and you should do this. So this is the same as I showed you before. Basically, you do the other thing first, before you get to the long-run optimal point. And this is maximizing benefits and presumably also profits to the industry. Presumably, however, global warming will occur gradually, so we can adjust on an annual basis or even on a daily basis, in which case the shift from this equilibrium to this equilibrium will happen gradually. This curve will not jump from here to here. It will move out slightly each year, things like that, in which case the optimal adjustment path is like this. So it's smooth. Oops. We do it this way. And this is actually the most likely outcome. If you're running a fishery and you're doing it in an optimal fashion and you're faced with global warming and the global warming affects your fishery gradually over time, which may not happen. There might be certain shifts in your fishery, but if it happens gradually, then your adjustment would also be gradual. And you would gradually increase harvest and biomass, year by year. Now, looking at the stochastic case, and again, I'm not going to tire you too much with the technicalities. The point is that we have certain theoretical apparatus to deal with that kind of a situation in a limited way, We are not solving the fundamental basic problem. We can solve simple variants of the basic problem. And the standard way to do it these days is to use these Wiener processes, Brownian motion, and use Ito calculus to do this. And for the technician in the area, these would be the basic equations. We are assuming that biomass evolves in a stochastic fashion. Basically, what we're saying is that the biomass growth function is going to be uncertain because of the impact of global warming. So it's going to evolve somehow, but how exactly we don't know. So we're assuming something like that here. So the biomass growth function, with biomass growth along the vertical axis and biomass along the horizontal axis, instead of having just one curve like this black one here, we have a sort of possibilities that it could be anywhere in this area. So it's that kind of an idea we are trying to express here. So we don't know, it's sort of foggy and uncertain, which of course is always the case, except under global warming, the fog is greater and the confidence interval are wider. Okay? So we go through the exercise. We need experts to do all these things. We maximize dynamically. We get something like this, and the outcome is going to be described by this. And you know, I'm not going to spend time on this. It's not going to be worthwhile. Except I'm going to go to this, and here's an equation that describes how you should behave if there is no uncertainty. But things are changing because of global warming, but there is no uncertainty about it. We know. We can measure everything, and we know how biomass grows and how the profit function changes and all of that. If there's uncertainty about these things, then this is the corresponding equation. And you can see just from the length of the equation that this is a more complicated equation. And this is what uncertainty does to you. Everything gets more complicated. Behavior is more intricate. And what happens here is that instead of having this change in the profit function here, dot means change, we need to have the expected change, you know, the predicted change, instead of the actual change. We cannot know the actual change, we have to predict it. So we get this E here, which is an expectation operator. Oops, what is this? My thumb is too big for this. Must be the Viking thumb, you know, this is designed for Spanish thumbs. And this is not sufficient, because we also had to add to the interest rate here, this term here, that comes out of the Wiener process. And this is the elasticity or the volatility. Business people will know all about volatility, you know, volatility of this and volatility of that and volatility of derivatives and financial assets, very, very common. But there's a volatility here of the biomass growth, and this is the elasticity of volatility with respect to biomass. How does the volatility respond to changing biomass? And this term here are various derivatives of the value function. So some of you are smiling because you all know what I'm talking about, and others are looking sort of frowning because this is complicated. Point is that uncertainty appears here and here. Oops. And we have to add two uncertain terms to the normal optimality conditions. So life becomes more complicated, basically. And the empirical task, of course, is to measure all of these things. To do research, measure biomass growth, and the uncertainty of biomass growth when you have global warming. And then, of course, the uncertainty of your profit function when you have global warming. And if you do that, we have people in this room who can do the calculations and tell you exactly how you should run your fishery. Well, not exactly, but certainly you know how much you should harvest each year. Okay, so the main findings are these. Global warming implies certain uncertain changes in commercial fisheries. Unfortunately, there seem to be very few rules of general validity. The uncertainty does not, the theoretical analysis of the uncertainty does not tell you how to respond to global warming. It tells you that it all depends. It depends on many, many factors. That's what we learn from the equations. So there are few, if any, simple rules of thumb here. Quite often you should do what is counterintuitive. A fish stock is being threatened, you should fish more of it. That can easily happen. So, to deduce the optimal response, we need research. We need to study empirically each particular fishery. We cannot rely on broad principles here. We have to study. Therefore, the usual policy prescription, more conservation, more protection, these recommendations are unlikely to be appropriate. They may be appropriate in some cases, not in other cases. Global warming increases uncertainty, maybe we should fish more, not less. The simple precautionary principle, if we have biologists in the audience, is not necessarily correct. Remember, we are thinking about the long term here. We're thinking about long-term sustainable fisheries, and precaution, in the sense of fishing less, may be the wrong move. About the only rule that I've been able to find that may apply in many cases is that the response to global warming may be myopic. It may be sufficient to adjust as changes happen. But that is not a firm rule. There may be conditions that invalidate that recommendation. If there's a high risk of a stock collapse leading to irreversibility, either complete or partial, then the optimal policy is probably to be extra cautious. But the precautionary principle here applies. If that is the great risk, that we somehow wipe out the stock. So, that finishes the theory. Now I want to look at the other part, the international shared stocks, and I'll have to do it very quickly. And we have different kinds, theoretically, different kinds of shared stocks. We have what we call straddling stocks that just are covered different fisheries jurisdictions and maybe the high seas. We have migratory stocks that move from different fisheries jurisdictions to others and maybe to the high seas. We have what is called highly migratory stocks that move over huge distances involving dozens of different countries. By my count, and this is a very, very rough estimate, I think perhaps 30 to 40% of the global marine catch can be characterized as being taken from shared stocks. So this is a big thing. Shared stocks is a big thing for the global fishery. Therefore, I say, efficient utilization of these stocks requires international agreements. You have to agree with the other nations involved, otherwise you cannot attain economic efficiency. Goes without saying. So, what is then of course, the nations involved are engaged in a game. They're playing a game with each other, some sort of a game. And this is going to be a bargaining game because it's possible to reach up an agreement, to have an agreement about how to utilize these stocks and enforce that agreement to a certain extent. So this is not a pure competitive game. There is a chance that you may reach an agreement with your fellow nations. This game is what I call a highly positive sum game. The gains from agreement can be very, very substantial. And that helps and facilitates the reaching of an agreement. Because the benefits are huge. It's not insignificant benefits from agreeing. It's big, in many cases, very, very big benefits from agreeing with your fellow nation about how to utilize your stock. On the other hand, there are variable fishing conditions, especially under global warming. Maybe the stock you're negotiating about is going to leave the fisheries jurisdiction of the other party. So their bargaining position is altered. So why should you give them a share in the fishery if the fish stock is going to leave them? So variable conditions are detrimental to agreement because it's difficult to maintain an agreement. It's maybe not even worthwhile to reach an agreement if the conditions are very variable and uncertain. And then if you have a high seas fishery over part of the migratory path, for instance, by high seas I mean outside any fisheries jurisdiction, in the common area of the ocean, then you may have new nations coming in, especially if you build up the stock. So the fishery becomes profitable. So new nations come in and they claim their share. And that's detrimental to an agreement. It's difficult to reach and maintain an agreement if that could happen. Anyways, this is a difficult bargaining game as proven by the experience around the world. Nations have been negotiating for years and years. Sometimes they reach an agreement that needs to be revised within a few years. Sometimes they don't even reach an agreement at great cost to both parties or all parties. Anyway, we can analyze this kind of a game using game theory, most common solutions for the games. The solution is the bargain. That is, in some sense, a stable bargain, stable agreement. We have the Nash bargaining equilibrium. We have something called Shapley values, something called nucleosis, and a few other concepts. It doesn't really matter what you apply, because they all come out with roughly the same solution to the game, same agreement. Agreement that reasonable people would reach and can maintain. More theory. Don't worry about the theory. This is based on Nash bargaining theory, very simple analysis. There are total benefits that can be reached from the fishery. If you do everything right, you maximize the total benefits from the fishery, then you can have X. You can, in this simple case, you can bargain about the shares in the benefits. How much of the total benefits this party is going to get, and how much the next party, and so on. So you bargain about shares. That's easier than bargaining about catch volumes or something like that. And then there is something in Nash bargaining theory and something corresponding to that in all the other theories called threat points, which is basically what each party can get if there is no agreement. How much do they get then? And this is a very, very important part of the negotiation, as you can guess. In any case, there is a solution to this game, or can be a solution, usually is a solution. And that solution is going to give you the bargaining shares, the reasonable agreement that can be maintained and rational people will reach in time if there are no problems in the bargaining. And the shares, the bargaining shares, are going to depend on the size of the benefits, which may vary because of global warming, total benefits, on the threat points of each party. So I is an indicator for party number I on the threat points. And the threat points are going to vary greatly under global warming because the fish move around. So they may move into a different area, maybe completely to the jurisdiction of France from Spain or Morocco or whatever. So that is an important part of the agreement. And if this is variable, then these shares have to be variable as well. And finally, there may be a change in the number of players. Or maybe the stock extends its range and there will be new players coming from, let's say, Korea or Taiwan or Japan, suddenly starting to catch your fish on which you have an agreement. And these agreements will be difficult, as I said, if X, the total benefits, the threat points, and the number of players varies over time. And this is bound to happen under global warming. It happens anyway without global warming. With global warming, there will be more changes. So the agreements are difficult to maintain because basically they will have to be renegotiated, as conditions change. Or the agreement has to be a super agreement saying this is the agreement under all possible conditions. So if the conditions change, then this applies, something like that. And I never heard about an international agreement that is exactly of that kind. Some business agreements may be of that kind, but not completely, even so. Okay, anyway, here is my final example, because this is a real-life example, and I know that people from Spain, especially fishing people from Spain, know about this problem, caused by global warming, at least warming in the North Atlantic, and this is the Northeast Atlantic mackerel fishery, involving my country, fighting with the European Union as usual. This is a sizable fishery. The spawning stock in 2009 was 3 million metric tons. There are 3 substocks. The western stock, the southern stock, and the North Sea stock. I'll go very quickly. This is the southern stock, close to Spain, so you probably fish from it. This is the western stock, and this is the North Sea stock, spawning areas. And here's where they winter. The western stock and the North Sea stock winter in this area. The southern stock is wintering here of Spain. The current fishery from the western stock is about 630,000 tons. Well, current from 2001 to 2008, average catches. Fairly big fishery, fairly valuable fishery, worth maybe 200 to 300 million euros per year. It's a multinational fishery involving the European Union states, Norway, and Russia. And that stands to reason. This is the area, the wintering area. You see Norway here, and you see the European Union, and then Russians are, in this area. Okay? The Norwegians always want to involve the Russians because they have so many fisheries dealings with Russia, anyway. Now, what is happening is that the Faroe Islands and Iceland are also harvesting. Why? Because of global warming or warming in the North Atlantic, the mackerel is now undertaking extensive feeding migrations. The stock is big, and it's moving towards Iceland in the summer for feeding purposes. And here are the Faroe Islands. And here are international waters. These waters here are international waters. And this is actually slightly outdated. The arrows go even further now. They go all around Iceland. And it's because of warmer waters. And warmer waters are a probable consequence of global warming. But it could be something else. But definitely the waters are warmer. Okay, so, and here's another indication of what happens. In 2006, there were the first signs of Atlantic mackerel coming into Icelandic fisheries jurisdiction. You see these dots here. 2007, much more fish coming into the Icelandic exclusive economic zone, right here. 2008, even more. 2009, even more. And you see they're going here. I don't have a picture for 2010, but by that time, the mackerel was all around Iceland. Okay. Anyway, Iceland and the Faroes are now taking 100 to 200,000 metric tons each, which is about half, or more than half, of the total allowable catch. And they are fishing the mackerel within their own fisheries jurisdiction, having full legal rights to do so. Meaning that the old agreement between European Union, Norway, and Russia is now outdated. There are new players, and they are fishing. So whatever agreement they have doesn't work. What do they do then? Well, they threaten Faroes and Iceland. Well, if you do this, we'll do something to you. But these are Viking stock people. They're not easily intimidated, so they just keep on fishing. This is now a serious international dispute, quite significant, with threats on both sides. And even more importantly, there's now serious overfishing from the stock because Norway, European Union, and Russia are still fishing their TSE, and we have the addition of Faroes and Iceland, so the stock is being overfished. And my question towards the end, because of global warming, is this the shape of things to come? Are we going to see this to a great extent all over the world? Fisheries, new fish wars, maybe. Thank you very much.